Alright, it's that time again. Time for Davidson's Greatest Hits. This would be volume 45, star date 10/20/10. And it's 10:30. That's a lot of tens. First off, parent-teacher conference was amazing. Thanks for all of you who brought your parents. It's nice to see where you people come from. Reeves, I have no idea how that works out, but whatever, if you know what I'm talking about. Anyway, let's turn in our notes and talk about the wave mechanical model. You have to kind of remember the history. We've jumped around on the history of the models of the atoms a ton so far. Let me just see how's the best way to do this. Just as a review real quick, we started with Democritus. He believed in roughly a dot that could not be broken apart. Then we went to Aristotle. He believed in a dot that could be broken into parts indefinitely. Alright. Then, his lasted for a really long time, but along came John Dalton. And his hypothesis based on his data was that it was just a dot, once again. An inseparable dot. We've called these atoms. This was called Heil. This is an atom again. Alright, then we start to get into the modern era where there's plenty of research tools. They can start to do nice experiments and come up with data that they can use to form their models. Alright, so we go from Dalton to Thompson's model. Thompson's model was the plum pudding model, where there was the positively charged. Sorry, I said that way backwards, and I even started to draw it backwards. There was the negatively charged plums, surrounded by a positive goo. That would be the pudding. Alright, that didn't last very long, because Ernest Rutherford, he discovered that there is something hard and compact in the center. It must be positively charged, and he hypothesized that electrons went around this positive center in rings. Alright, Bohr comes along. He's going to come up and say, alright, there's that positive thing. And electrons reside in rings, and it can move in between rings by gaining or releasing energy. Alright, so that's where we are so far. But Bohr had a problem with his model. Alright, and this will make sense in the notes in a minute. Alright, so here's Bohr's model. He couldn't explain something in his own model. The problem that he had is he believed that if this model is really true, that the electron as it orbited would eventually fall into the nucleus. Alright, that would neutralize protons. We'd have the electrons falling in, and we would not even have any atoms, so we would have no matter. Alright, so even though he had this model, he really struggled with the thought that according to physics, the electron should slow down, lose energy, and fall into the positively charged nucleus. Alright, so his model couldn't quite explain that. Now, he had some theories, but it took more research and mainly some mathematicians to figure out the real model and the model that we most currently believe the atom to be. Alright, that model is going to be called I hope that you enjoyed that. I was trying to get to that pause button, but I didn't quite get there. So excuse me, my own wife's laughing at me. So the next model we're going to study is this model that's up here at the top, and it's called the wave mechanical model. Alright, so we're going to go ahead and fill that in, the wave mechanical model. We'll do that in the next couple slides.